Hello everyone. Today in this lab we will discuss TensorFlow variables. So this will be lab 3 actually. In the earlier 2 labs, what I had done is I discussed constants, TensorFlow constants. So today we will discuss TensorFlow variables. So let us discuss what they are and what is the difference between the variables and constants. Let's go one by one slowly, and then you will get a good grasp of what exactly this TensorFlow variable is and where it is used in the area of deep learning and machine learning. So let's go. So today the first exercise that we will do is we will actually create the variables. So there are three different type of variables that you can create: scalar variable, vector variable, and the matrix variable. So let's discuss all of them and how they are defined in the TensorFlow programming. So the very first thing which you all know is required is to import TensorFlow as TF. So let us import this. Okay, so it's executed. So now the very first thing that we see here is three different examples of defining the TensorFlow variable. One is scalar, vector, and the matrix version of these variables. The scalar version of these variables is defined as TF dot variable 2. Please note here the it's not like the constant where c is small over there. So the v in the variable is capital. So it will throw an error if you write a small v over here. And then what you do is you define that variable as, like, if you define it as a scalar, it will be 2 here, and then you can name it also in a separate way, like name is equal to scalar over here. In case you want to name it something else, you can write it something, so you can write something else also. It's just the nomenclature that this particular TensorFlow variable provides with the argument name. And then if you want to define it as a vector, then you have to define a vector like this. So it's a two-dimensional vector which is written over here. So basically I can make it as a one-dimensional vector as well. So let me keep it that way because we already have a matrix. So matrix example. So this is the one-dimensional vector, and then we have matrix definition, which is actually defined like this. So you can see I have defined a matrix which looks like this, and let's print these examples in the form of scalar, vector, and matrices. Let me show what the results are once you print it. So here you see, in the case of variable, you are getting a numpy value as 2, whereas in case of one dimensional vector, you are getting the answer as 1 2 3. And then in the case of matrices, you are getting the answer as this over here. The important thing that you want to note here is that in this case of matrices, it's okay that your shape is 3 comma 3, whereas in this case it is returning as 3 comma something. So this is again a very confusing thing. So in order to avoid this, what you can do is you can put the double brackets again. Then what you will get is the exact dimension of this one dimensional vector, which is 1 comma 3. Whereas in case of variables, you are getting a numpy value of 2 and there is no specific dimension of it. In case if you want to print the numpy values, because right now it is returning basically a tensor. So now if I want to print the numpy values, then what you can do is, I think I have done it. Okay, I have already done it here. So let me show you that. So this example prints out the tensor variables. Now if I want to print out the numpy variables, then what I can do is I can run this particular piece of code, and now you see you're getting the numpy results, like in the form of matrix, vectors, and scalar values. So tensor is detached and you are getting the numpy answers. So in this way you can actually implement the scalar, vector, and matrix tensors in the form of variables. So another important thing that I want to discuss is you cannot actually, once you have defined the variable, like for example here I am defining scalar underscore example, I cannot add 3 directly to this particular variable. So let me run this and show it to you. So once you see here, I cannot directly add the value to the scalar tensor because this is not allowed and it's not possible to do it. So it will not be able to give you the results as it's not allowed. So if I print the value also, then also you will see that it's not giving you the value because it is not supported. So direct addition is not supported, where this was not the case in case of constant. So if I define, let us say, I already discussed last time also, let me define a constant variable like 4 here, and then if I print cost plus 4, then it will print the values. So here you see it has added 4 to the already existing constant, which is 4. And this particular addition, direct addition, is possible in case if you define if you define this cost as a constant. If you define this as a as a tensor, then this direct addition is not possible. So this is a basic difference between the variable and the constant tensors. So this is very important, so you have to keep that in mind. So how to update the values in the variable if you cannot do direct addition and multiplication? So in that case, what you can do is you can actually add the value 3 by using assign underscore add. So if you call this particular function, then what it will do is it will actually add to the existing value of the scalar example. So here if in the earlier case, a scalar example value was 2. If you can see over here, it's 2. So now if I add 3 into this scalar example, and then if I run this particular piece of code, then you will get 5 as the answer. So here you see this is the 5 answer which we are getting. This 5 is because you are actually converting the tensor into a numpy value by calling this numpy function, and then what it will do is it will give you the value 5 out of this. Otherwise it will return a tensor. So now you know that how to add the values into the variables, tensor variables. You cannot directly add them, but you have to call the function. Similarly, if you want to replace the value, like for example earlier the value of scalar example was 2, then we have added it and added 3 into it and we got 5. So now if I want to replace this value, what I can do is I can use assign function, and if I am assigning 10 to it, then what it will give is it will give you 10 as the answer. And you can actually detach this tensor by using numpy as well. So here if you run this, you will get 10 as the answer. So it has replaced 5 value by using assign function. Similarly, in the case of matrices also, what you will get is, if like for example, let me print the matrix which we wrote earlier. So let me print this. So in the case of matrices, let us see what we will get when we do this assign operations. So in the first printout, I am just printing out the matrix example which we had loaded earlier, and then what I am doing is I am detaching it as a numpy, so that we can see the matrix without the tensor output. In the second case, what I am doing is I am replacing the specific element at the 0th row and the first column by 7. And in the third case, what I am doing is I am replacing the second column of the matrix with the values 0, 40 and 60. So let us run this and see the results. So here you see in the first case the original matrix is 2, 3, 4, 4, 5, 6, 7, 8, 9. And in the when you assign a specific value of 7, and that specific value of 7 will actually replace this 3 element which is at the location 0, 1. So you can see in the second matrix here 3 is replaced by 7. Whereas in this third operation, you see here what I am doing, the second column, this second column is actually this second column is actually replaced by 0, 40 and 60, which you are actually putting out here. So now you can see how you can actually replace the matrices also, but using the assign functions. Similarly, you can do addition as well in the specific elements of these matrices using the assign underscore add function. So these are the nitty-gritty details that actually make a difference between the variables and the constants. And another exercise is like if you want to do the simple addition of the variables, then this is possible, that if two variables are defined in the tensor format, like for example variable 1 and variable 2, it is defined as 3 and 4, and then what you can do is you can actually use simple additions using plus and multiplication using multiply operator here. So let me run this and you can see the result. So now here it is very simple. You have defined two variables 3 and 4, which are actually added as 7, and in multiplication it will give you 12. So this is possible, that if you define two different variables and then operation between them can be done using addition and multiplication operation. Thank you for watching my lecture. This is the basic idea about TensorFlow variables. Next we will discuss some advanced concepts involving this TensorFlow variables. Thank you.